Hi all, Dmitry is here. Welcome to my next video about battery testing. Today we will create a design for a new testing setup and a new testing device. As you saw in my previous videos, my old setup has some problems. For example, setup was unreliable due to lots of connections. It requires a PC for data logging. Here we had a Tinker board. With this setup, due to voltage losses on the contacts at high currents, it might shut down too fast and show less capacity that battery really has. And discharge current and capacity was measured by IMAX, while voltage logging was on ESP32. So we had lots of components, lots of potential problems. So because of that reasons, I decided to create a new test setup. It should not require a PC for data logging and it should be easy to use. And also I want to get rid of the IMAX as a load current controller. And here is the schematics of new setup. ESP32 will be used to control the process, and also it will be act as a logger. It will log the data inside its internal memory, and later this data can be downloaded as a CSV files. As an adjustable load, bipolar transistor will be used. For limiting and measuring discharge current, I also added 10 watts resistor with low resistance 0.22 ohms. And ESP32 will be also measure voltage of the cell itself and voltage after the resistor. Having the ability to control discharge current dynamically also opens interesting possibility to measure the internal resistance of the cells. I made a video about reviving rechargeable cells, where I explained why internal resistance matters, so make sure that you saw it. In short word, for digital devices, low internal resistance can be even more important than capacity, because if your batteries have high internal resistance, device might not work, no matter what capacity your battery has. So now I can measure this also. With a battery tester like this, I can make a comprehensive comparison of different batteries. Actually, at the YouTube you probably will not find a lot of battery tests with internal resistance of the batteries comparison. And yes, just trust me, it matters for the digital devices like cameras, car alarm, remote controllers and some sensors, a lot of them. Actually, it was a long time from moment when I started to design this scheme and to the moment when I filming this. So actually I made this device already. Let's take a look at it. First, let me clean up this a bit. And here we have a new tester device itself. Let me adjust the focus. Okay, now it looks better. So here we have a good battery holder. It has good contacts with it's spring loaded. So now contact will be good for sure, and it has 4 wires connecting circuit. So we have 2 wires for the current and 2 separate wires and 2 separate contacts for the voltage measurement. So right now we can for sure know that at high currents it will looks good and will works good. And also we have a small OLED display that shows current system status, is it run, is it stop, and it shows also IP address of the system and current parameters like capacity, current voltage on the battery, and so on. Here is the web page. I'm not sure if I can focus on it. Oh yeah, looks like I can. Here is the web page for the battery testing setup. As you can see, here we can set end voltage of the discharge when it will stop, discharge currents, watch current status, run or stop the process, and at the bottom we have links to download CSV files with current values, not current, with archived values. So when you start the test, it logs, every minute it logs current voltage of the cell, current capacity, current energy, and internal resistance to the internal memory. And when test ends, you can download this and watch what happens. You can build the graphs, you can analyze the data, and so on. It will measure internal resistance only one time per 10 minutes because actually it requires high current, and I don't want to over discharge the batteries with that measurements. I don't want to interfere with test results. So it's not measured in real time. Other values archive it in one time per minute. Let's take a look inside. So what do we have here? Actually not too much. Here you can see ESP32 itself, a transistor, and high powerful low resistance resistor as a current limiter and as a current measurement device. And actually that's all. Here is wiring to the OLED display. So with device like this, I will able to make battery tests more comprehensive, more informative, and I really hope that it will be more interesting for you. Thank you for watching and stay tuned. I hope it will be interesting and fun. Thank you. Bye.